Which of the following points are solutions to the equation 3x minus 3 over 2y is equal to 4? Now, what are we trying to do here in this problem? Essentially, we're asked to give a yes or a no answer for each of these three ordered pairs or points. So for each one of them individually, the answer is going to be a yes or a no. Yes, that point is a solution to the equation, or no, that point is not a solution to the equation. Now, what is a solution? What does this word mean? Solution. Well, we throw this word around in mathematics quite a bit, and it's not always the case where everyone really literally understands what that word means. In mathematics, we're looking for truth. In the context of solving equations or finding solutions, we're looking for truth. So let me give you a more basic example than this equation up here. Let's say x plus 2 is equal to 5. Right? This is an equation. It has one solution. Some number plus 2 is equal to 5. Well, if we put the number 6 right here in place of the x, so we replace x with 6, we get a false statement. Right? 6 plus 2 is 8, and 8 equals 5. That is not true, so 6 is not a solution. If we plug in a 15, for example, 15 plus 2 equals 5. Well, 15 plus 2 is 17. 17 equals 5. Also false. But there's one number that we could plug in. In this case, it's the number 3. So if we replace the x with the 3, that gives us 3 plus 2 is equal to 5, which is 5 equals 5, which is a true statement. So this is what solutions are. Solutions to algebraic equations are numbers that lead to a true statement. Numbers that lead to a true statement. Okay, so now let's apply that up here. Let me get rid of some of this because I'm going to need some board space. So let's look at the first point. 3 comma 4. Well, what that is saying is x is equal to 3 and y is equal to 4. Now, does that work in this particular equation? Well, here's our equation. 3 times x minus 3 over 2 times y is equal to 4. So what we're doing is we're replacing the x with the number 3. Okay, we're replacing x with the number 3, so let's do that. 3 times 3. And we're replacing the y with the number 4. So let's go ahead and do that. Replace the y with the number 4. So times 4. All right? Everything, I'm going to go back to my highlighter up here. Everything is based on this equation. This equation I just highlighted in yellow. So we took that, we replaced the x and the y with the numbers 3 and 4, and then basically see what happens. See what happens. Well, 3 times 3 right here. 3 times 3 is 9. So we get 9 minus 4 times 3 over 2. Well, 3 over 2 multiplied by 4. We could treat that 4 like it's a fraction. 4 over 1, and top times top, bottom times bottom. 3 times 4 is 12. 2 times 1 is 2. Remember, fraction means division, so 12 over 2 means 12 divided by 2, which is 6. So we get 9 minus 6 is equal to 4. 9 minus 6 is 3, and I know 3 is not equal, it is equal to 3. 3 is not equal to 4, so this is a false statement. This is a false statement. So our answer is no. That one's not a point. Oh, it is a point. It's not a point on the line associated with this equation. So it's not a solution to this equation. Okay, so we got to do the same thing for each of the 3 points. Right, we've got the equation 3 times x, and I'm just going to rewrite the equation each time, and then we'll replace these variables. Okay, so we're taking the number -5/3 and replacing that for the letter x, right, for the letter x. Then we're taking the -6 and replacing that in for the letter y. So we'll multiply 3/2 times -6. So erase the y, put in a -6. And then we just have to see what happens. Is this true? Well, let's multiply it out. 3 times -5/3 is -15/3 minus, well, 3/2 times a -6. 3 times 6 is 18, so that's a -18/2, but we already have a minus sign in front, so 2 minuses make a plus. Oh, not 13. It's going to be 18/2. Is equal to 4. Is that true? Well, 15/3. These are both whole numbers. They look like fractions right now, but they're whole numbers. 15/3. Remember, fraction means division. So 15 divided by 3 is 5. So that's -5. Plus 18/2 means 18 divided by 2, which is 9. And if you take -5 and you add 9, you get 4. So we end up with 4 equals 4. That is a true statement. So the answer is yes. This point is a solution. Not the only one. There are infinitely many solutions to an equation when that equation has 2 different variables, 2 different letters in it. All right, so last one. We've got 3. Let me go back to the blue I was using. 3x minus 3/2 times y is equal to 4. Same as before. The first number is the x. That's being replaced in for the x. So that x becomes a -3. The second number is the y. That number is being replaced in for the y. So let's go ahead and erase that y and put in a +6. -3 times -3 is -9. Then we've got minus. 3 times 6 is 18. So that's 18/2 equals 4. Well, we don't know if it equals 4. -9 minus 18/2 means 18 divided by 2 again, so that's another 9. 9, or -9 minus 9, so we're getting more negative. That is -18 is equal to 4. I know that's not true because the only number that's equal to 4 is 4. Right? So that is false. So the answer is no to that one. So which of the following points are solutions to the equation? Just that one in the middle. Okay, but it really, so much of what we do in math comes down to our definition. So like, what does it mean for a point to be a solution? What is the definition of solution? Well, they're number or numbers that lead to a true statement. When substituted into your equation, lead to a true statement. Okay, next one's going to be much quicker than the first one, but also hinges on whether or not you know the definition of one of the words in the problem. What are the intercepts? What are the intercepts of the graph below? Well, what is an intercept? What does this word mean? Without the definition, you can't do the problem. So intercepts are points. Intercepts are points on a graph. Specifically, intercepts are points. So an intercept is any point that contains the number 0. Any point that contains the number 0. So you could have a 0 for the x, and you could have some number for y. You could have the 0 for the y, and then any number for the x. Right? The first one is called the y-intercept. And the second one is called the x-intercept. So what does that mean on the graph? Well, if a point contains the number 0, then that point has to be somewhere on the x-axis if it is an x-intercept. Somewhere on the x-axis if it's an x-intercept. And it's got to be somewhere on the y-axis Sorry, it's easier to draw horizontal than vertical with this highlighter. So x-intercepts are points where y is equal to 0, or they are points on the x-axis, and the y-intercepts are points where the x is 0, or points on the y-axis. So let me make these points here a little bit bigger so everyone could easily see them. There's a point right about there that's labeled on the graph, and there's a point right about there that's labeled on the graph. So what are those points? We're looking for those points, the intercepts, and we could read them directly off of the graph. So each of these little squares on the bottom, on the graph, each of these little squares on the graph, one of these is 1 unit. So this black point on the green, on the x-axis, looks like it's at the point 4. So 4 on the x-axis over 4. So everything is relative to the origin. So over 4 and up 0. So there's your x-intercept. And your y-intercept, well, there's 5 right here, 6, 7. So it looks like 7 on the y-axis. So 0 for the x, 7 for the y. Those are your intercepts. The 0, 7 is on the y-axis, so we call it the y-intercept. And the 4, 0 is on the x-axis, so we call that the x-intercept. All right, one more problem, again, though, dealing with intercepts. In this case, I think it's the easier version because we're just looking at a graph. We don't have to do any calculations. The next problem, again, what are the intercepts? What are the x and y intercepts of the graph of the equation y equals 4 over 5x plus 8? Y equals 4 over 5x plus 8, and y equals 4 over 5x plus 8. Why did I write it twice? Well, there's 2 types of intercepts. Right? There's the x-intercept and there's the y-intercept. We have to find both. So I'm going to go back a slide. Oh, I can't go back a slide. Well, just to review what we talked about on that previous slide, the x-intercepts. So let me write this down at the bottom. X-intercepts look like this. Any number for the x value, but 0 for the y value. So x-intercepts happen when y is equal to 0. And then the y-intercept is any point that looks like this. 0 first, and then any number for the y. 0 comma anything. It would be a y-intercept. So the y-intercepts are happening, they're occurring when x is equal to 0. All right, so that's the definition. That is in red, that is the definition of the word intercept for the x-intercept and the y-intercept. So let's apply that up here. And if we want to find the x-intercepts, you got to put in a 0 for the y. If you want to find the y-intercept, you got to put in a 0 for the x. All right, so let's do that, just like we did in the last problem. That x should stay there, but we're taking away the y and we're putting in the number 0. For the y-intercept, we're doing the same thing, but for the x. All right, so it's like two separate problems. For the x-intercept, you plug in 0 for y, and then solve for x. All right, so I see a fraction, 4 over 5. I like to get rid of fractions, eliminate fractions in the very first step. So first thing I'm going to do is take this equation and multiply both sides by 5. We can multiply by 4/5, but I don't even like to work with the fractions. So I just look at the denominator. That's division. So we do the opposite, multiplication. 5 times 0 is 0, so you still got a 0 on the left. And then the 5 has to multiply to both terms on the left-hand side, or on the right-hand side, sorry. So we have to do 5 times 4/5 x and 5 times 8. Well, 5 times 4 over 5, the 5's cancel. The 5's cancel, so that would be 4 times x. And then 5 times 8 is 40. We can subtract 4x from both sides. We want to get x on one side and numbers on the other. So that'll give us negative 4x is equal to 40. Now, if you take a slightly different path through this problem, that's perfectly all right. This is one way to get through this problem. There's a few different ways we could solve this, but we're all going to get the same answer if we don't make any mistakes. Right? So then we want x by itself. We could eliminate that times negative 4 with a divide by negative 4. We do the opposite or the inverse operation. So we get x is equal to, well, 40 divided by negative 4 would be negative 10. So we could say the x-intercept is negative 10, or the point negative 10, comma, 0 is on the graph. Y-intercept is a little bit easier just because simpler is a better word than easier. It's just one step. 0 times anything is 0. So we get y equals 8. Right? 4/5 times 0 is 0. Anything times 0 is 0. So we get y equals 8, or the point 0, comma 8 is on the graph. Now, we're not told to graph the equation, but we could very easily now because we have 2 points, right? And that's the whole point of graph. Like, this whole point of working with the equations leading up to a graph is the minimum amount of information. What you need to make a graph of a linear equation is 2 points. And if you have the x-intercept and you have the y-intercept, you have 2 points. So you could put those 2 points on the xy plane, draw a line through them, And there's your graph. Okay, that is it for this video. I hope this was helpful.